Hello student. So for this mid exam uh, we will solve some of the numerical, and that those numerical will be helpful to you uh, for mid exam. So now initially we will cover examples of fin. So in that I will explain you first of all basic formula that we are generally using to solve numerical of fins. So here you can see that these two equations are important. 1 minute. These two equations are important. So now in fin, basically three type of fins are there generally in our syllabus. So first is heat dissipation from an infinite long fin. So if length of fin is infinite, so we will have to use this formula. Second type is the end of the fin is insulated. So suppose here we have fin, and if at the end if it is insulated, so at that time we will have to use this category, formula of this category. And if fin losing heat at tip, so if fin length is finite and if heat is being released from tip, so at that time we will have to use this formula. So three types are there: fin having infinite length, fin insulated at tip, and heat loss fin which is losing heat at tip. Clear? So according to that we will have to use formula. So for that, here you can see, now this formula we will use to find out temperature. તો આ પહેલાં સમજી લઈએ કે આ જે છે પહેલાં આપણે અહીંયા ડ્રો કરીએ ફિન. સપોઝ હિયર વી હેવ વોલ. અહીંયા આપણી પાસે આ વોલ છે. એ વોલમાં આપણે શું લગાવેલું છે? ઇન ધેટ વોલ વી હેવ this is our fin. Clear? So this is our fin, this is our wall. So now wall temperature is known as TO. Remember that. Atmospheric air temperature is known as TA. What is K? K is conductivity of fin. What is H? H is a heat transfer, convective heat transfer coefficient. Clear? Now then after initially try to understand the term. So I am telling you term. So then after T. What is T? T means suppose you want to measure temperature at X distance. Clear? So whatever temperature you got, so that is known as T. X. બરાબર, તમે એક્સ ચેન્જ પણ કરી શકો. એક્સ ચેન્જ થાય તો ટી ચેન્જ થઈ જશે. એ રીતે અહીંયા તમે જોઈ શકો છો કે આ જે ઇક્વેશન છે એમાં ટોટલી ટેમ્પરેચર કોના પર ડિપેન્ડ છે? એક્સ પર. તો આ ઇક્વેશન જનરલી કોના માટે યુઝ થાય કે પર્ટિક્યુલર એક્સ માટે ટેમ્પરેચર ફાઇન્ડ આઉટ કરવું હોય તો આ ઇક્વેશન આપણે યુઝ કરીએ છીએ. કે ધારો કે 0.5 મીટર અથવા 0.1 મીટર કે કોઈ બી ડિસ્ટન્સ હોય તો ડિસ્ટન્સ ચેન્જ કરી એની સાથે ટેમ્પરેચર ચેન્જ થશે. તો આ ઇક્વેશન જનરલી આપણે પર્ટિક્યુલર ડિસ્ટન્સ પર ટેમ્પરેચર ફાઇન્ડ આઉટ કરવું હોય તો એનો આપણે યુઝ કરીએ છીએ. બરાબર છે? આમાં તમે જોઈ શકો છો ટીએ શું છે? એટમોસ્ફિયરિક ટેમ્પરેચર. ટીઓ શું છે? ટેમ્પરેચર ઓફ બોડી at which we have used fin. What is M and what is X? X I told you. Now M is unknown. M you do not know, but formula for M would be pH by A cross section into K. This is formula. Now what is H that we know? What is K that we know? What is area of cross section that we know? Now area of cross section means suppose this is area we will have to consider. આ એરિયા આપણે કન્સિડર કરવો પડે. આ શું છે? બી છે અને આ સપોઝ આપણે વાય છે. તો એરિયા ઓફ ક્રોસ સેક્શન કેટલો થશે? વોટ વિલ બી ધ એરિયા ઓફ ક્રોસ સેક્શન? ઇટ વુડ બી બી ઇન્ટુ વાય. સો ધીસ ઇઝ અવર એરિયા ઓફ ક્રોસ સેક્શન. નાઉ પેરીમીટર ઓલ્સો યુ વિલ હેવ ટુ રિમેમ્બર. નાઉ પેરીમીટર મીન્સ બી પ્લસ વાય પ્લસ બી પ્લસ વાય. સો વોટ વિલ બી ધ ફોર્મ્યુલા ફોર પેરીમીટર? 2b plus y. Now if our fin is circular, then what would be the formula for perimeter? for perimeter, formula would be pi d. And what would be the formula for area of cross section? Pi by 4 d square. So now you will have to remember that what is difference between this area and perimeter. So all term understood by everyone? All term we know. Now second formula is heat transfer rate. Now if we want to find out heat transfer from body to fin, so at that time which equation we will have to use? કઈ equation આપણે use કરીશું? We will have to use this equation. કયું છે? આ જે equation છે ને Q fin વાળું, આ equation use કરીશું. તો પહેલા આપણે એક કેટેગરીના જ ન્યુમેરિકલ જોઈએ કે heat dissipation from an infinite long fin. So which equations are helpful to us? These equation and this equation. These two equation we will use. So for that let us read data and let us try to solve numerical. So here we have data. This is data. 1 minute. Or according to this data we will draw our diagram. So calculate, or let us initially draw diagram. Calculate the amount of energy required to solder together two very long pieces of bare copper wire 1.5 mm in diameter. Now here fin is given, that fin is circular. So here whatever fin we have, so here it is told that fin is circular. That fin is circular. Clear? So here we have body. Suppose this is a surface from where we want to remove heat. So here what is the diameter given? Diameter is 1.5 mm. So this is diameter 1.5 mm. So here we have this diameter is 1.5 mm. You will have to convert it in meter later on. ચલો એના પછી શું આપેલું છે? With solder that melts at 190 degree centigrade. So 190 means which temperature? It is a temperature given 190 degree centigrade. 190 degree centigrade. Then after, the wires are positioned vertically in an air at 20 degree centigrade. Air temperature is also given. What is air temperature? 20 degree centigrade. Then after, assume that the heat transfer coefficient on the wire surface is 20. So H given, watt per meter square degree centigrade. Conductivity is also given. Conductivity 330 watt per meter degree centigrade. So conductivity is 330 watt per meter degree centigrade. Clear? So what we will have to find out? Find out શું કરવાનું છે આપણે જોઈએ. So calculate amount of energy required. So energy required or heat flow we will have to find. So we will have to find out heat transfer rate. So what is formula for heat transfer rate? So this formula we will use. Which formula we will use? We will use this formula. So what is formula that you will have to remember? PH and TO minus TA. So here Q is equal to under root PH area of cross section K, then TO minus TA. Clear? So now we will write down all the term. So initially what we did, we will write down all formula. So here what would be the formula per perimeter? It would be pi d. Now d means 1.5 into 10 raised to minus 3 because that is in mm, pi d. Then what is h? H given 20. Then after area of cross section, what would be that? Pi by 4 d square. D square means 1.5 into 10 raised to minus 3 square. Then after k means 330. Okay, so this is under root. And then after, here what you will have to write? TO and TA. What is TO? Let us check that. TO is 190 and 20. So here no need to convert in Kelvin because both are in degree. Difference we will have to take. So in difference, now this we will have to calculate. આપણે calculate કરવાનું છે. તો પહેલા શું કરીએ? Pi into 1.5 into 10 raised to minus 3 into 20 into shift pi into 1.5 into 10 raised to minus 3 whole square into 330 is equal to, divide by 4 is equal to, under root answer is equal to, into 190 minus 20. So answer is 1.26. So let us check that answer. Okay, so here you can see that this is answer 1.26. So here we will have to connect two circular rod. So both direction heat get flow. So you will have to multiply with 2. બરાબર ને? અહીંયા બે રોડને આપણે જોડવાનું છે ને, અહીંયા બે રોડને કનેક્ટ કરવાનું છે. તો આન્સર શું આવે છે? 1.26 વોટ આવશે. હજુ અહીંયા આપણે બે ફિન જોડવાની, બે રોડ જોડવાના છે ને, તો એક રોડ અહીંયા બી આવશે, એક રોડ અહીંયા બી આપણે કનેક્ટ કરવાનું છે. તો હીટ તો બંને ડિરેક્શનમાં ફ્લો થશે, તો પછી એને મલ્ટીપ્લાઈડ બાય 2 તમારે કરવું પડશે. સો ધીસ વોઝ અબાઉટ અવર ફર્સ્ટ એક્ઝામ્પલ. So next time we will solve basically 5 to 6 example you will have to prepare for this exam. So I will give video for each and every example. So thank you all for listening.